Okay, today we're going to talk about multiplying binomials, and this is pretty much a review, okay, if you think about it. So let's look at our first example. X plus 5 times x minus 4. So you can see we have two binomials multiplying. Do you think it's a good idea to change its addition first before I do multiplication? Before I multiply? Yes? No? No? You don't think it's good? Yeah, it's a good idea, right? We got x plus 4, so why not change it to x plus negative 4? Is that okay? Then, of course, who remembers how to multiply these binomials? Yes, Sarah?
Do x times x.
X times x.
And then
X times negative 4.
And then
5 times x and?
5 times negative 4.
And in between each of these terms, what operation is there? When you do these? So when you multiply like this, right? What operation is going to be between? First, you get x squared, right? Then what? What operations are going to be in between each of these terms? Yes? Addition, because we change everything to addition, right? You're going to have addition as your operation. So everybody go ahead and try. You should all. This is review, isn't it? We've done this before, haven't we? Okay. Tell me what you get. All right. Jamin, tell me what to write. Yeah, so you get x squared plus negative 4x plus 5x, right? And aren't these two like terms? So what do we get when you add them together? You get?
X squared plus x minus 20.
There you go. There you go. Very good. Any question? Nothing difficult, right? We've done this many times before, haven't we? Okay. Now, if that's the case, then it turns out there's another method, another way of multiplying these two. It's called method 2. This method is kind of interesting in that instead of like multiplying each of these term first term and then and so forth, you could actually think of this. You could use distributive property. What I mean by that is, think about x plus 5. You know, when you distribute something, you usually distribute a monomial, right? Turns out you could actually distribute a binomial. So you could actually distribute x plus 5 to x and to negative 4. Do you know what I'm trying to say? So let me show you what I mean by that. So using the distributive property, instead of doing it for monomials, we could actually do it for binomial. X plus 5 times x plus what? X plus 5 times what? Negative 4. Not too many people do it this way, but do you think we still get the same answer? Yeah, it's actually, you know the way that we did before? It's a shortcut of doing it this way. So this is the actual correct way of doing it. But anyway, go ahead. See if we get the same answer. Everybody try. All right, so who can tell me what I get when I multiply this whole binomial times that first term? Yes.
X squared plus 5x.
Good. And
Negative 4x. And plus a negative 20.
that's right. Now, do we, and when you, of course, gather the like term, we have like terms, don't we? 5x and negative 4x. What does that become? Yeah. X, right? So tell me the whole thing now, Benjamin. X squared plus x minus 20 is the answer. Any question? Does that make sense? Okay, good. Then let's move on. So, like I said, not too many people do it this way, but this is actually why we were able to do that first method. Okay, they did this many times, and they go, wait, we could actually just, a lot of you know this as FOIL, but I don't really do FOIL. But anyway, you multiply each of these terms, same way. Okay, let's look at then example 2. Go ahead and hold on a second. Okay, go ahead and multiply this one, example 2. This one's a little bit interesting. Look at the two binomials. Do they look pretty similar? But there's one thing that's different. What's different in these two binomials? Yes, correct?
One's addition and one's subtraction.
One's addition, the other is subtraction. But all the terms, everything looks exactly like, except one of them is addition, the other exactly right. Go ahead, everybody multiply it out, see what you get. This one comes out to be kind of interesting, okay? And we're going to be looking at this a little bit more later in another section. But everybody go ahead and multiply it out, see what you get. All right, so Rachel, tell me what to write here. what do I get when I multiply this?
9x squared.
Uh-huh. Oh, I changed it to addition first. Is that okay, Rachel?
Yeah.
Okay, then what 9x squared.
Plus negative 12xy.
Mm-hmm.
Plus 12xy.
Mm-hmm.
Plus negative 16y squared.
Good. And Rachel, do you notice anything interesting?
Negative 12xy, 12xy cancel out.
Yeah, they go away, and then we just get 9x squared minus 16y squared. How many people got this? Raise your hand. Good. Do you see how the middle terms cancel out? So as we do these, I would like you to be thinking about how we could go from. So this is kind of a review, and you may think, well, why are we doing this again? Well, later we're going to try to go from 9x squared minus 16y squared to what it was before. You know what I'm talking about? What do you think they will say as an instruction? Their instruction. What sort of instruction would they say if we go from 9x squared minus 16y squared? Would they say simplify? What do you think they're going to say to tell you to do? Yeah, factor is correct. You see how this was a difference? Now, how do we write this as a multiplication? So we're going to try to do that later. So as you do the homework tonight, think about how we could go backwards. Yeah, Alvin, did you have a question?
On the example 2,
Yeah.
so what I do is when it's the same and when it's a positive and negative,
Uh-huh.
I just multiply 3x and 3x and therefore I pop y and
Hmm. Yeah, and how did you know that these two things cancel out?
because then they're the same numbers, so the middle two numbers are going to cancel out.
Very good. Actually, we're going to talk about that. It turns out that if the two binomials looks exactly the same, except one of them is addition, the other is subtraction, the middle term will always cancel out. So if you know that, then anyway, so that's what we're going to kind of use. We're going to that's very good. We're going to use those kind of patterns to see how we go from here to factor it. So, but if you don't see it right now, no worries. Okay, we'll get there. But kind of think of it like even example 1, we're going to try to actually go from this trinomial to factor this trinomial so it becomes x plus 5 times x minus 4. So we're going to be kind of working on that. That's what that quiz is going to be on Tuesday. Does that make sense? So anyway, if you don't see it right now, that's okay. But kind of as you do your homework, kind of keep that in mind. All right, let's look at example 3 then. This time, instead of just x, you have x squared, and here again x squared. But does that change anything too much? Not really, does it? Okay. Go ahead, everybody try to multiply and see what you get. I'll wait for you. Alright, so I changed it to addition to everything to addition first. Alright, let me see, how about, who wants to help me how to do this one? Anybody? Viviana, can you help me?
So after you do that, it would be, you multiply it and it would be 18x to the 4th.
Good, it's 18x to the 4th, isn't it? Is it 18x to the 2nd power? No, what's x squared times x squared, guys? X to the 4th, so Viviana is correct, you get 18x to the 4th, then what?
Minus 12.
Minus 12?
Minus 12x squared.
Okay.
Y.
I changed everything to addition. So what operation is going to be between each of these terms?
Plus.
Plus what?
Negative
Good.
12x squared.
Mm-hmm. Negative 12. Oh, you actually did everything? Let's just do it together. So don't we get negative 6x squared y first? Then plus what?
Plus negative 6x squared.
Good.
Plus 2y squared.
Plus, because it's negative times negative, plus 2xy squared, 2y squared. And Viviana, you're right. What do we get at the end? We get
18x to the 4th minus 12x squared y plus 2y squared.
good. Does that make sense? Now again, we're going to try to go back. If I have this trinomial, we're going to try to factor so that it becomes 6x squared minus 2y times 3x squared minus y later. So as you do your homework tonight, kind of think about how do you see if you see any patterns or how we could actually do that. Okay. But anyway, okay, good. How many people got this right? Raise your hand. Any question? It's just pretty straightforward. Nothing difficult. Okay, good. All right, let's move on then. So it turns out that let's switch your gear a little bit. Let's do some vocab work here. Each terms of a trinomial that looks like this, 6x squared plus 7x minus 20, has a standard name. Okay, each of these terms. By the way, this is written in standard form. But anyway, 6x squared plus 7x minus 20. Each of these terms, what do I mean by each of the terms? What am I talking about when I say each of these terms? What are the terms for this trinomial? Can somebody tell me? Yes.
6x squared.
Good.
7x and
Uh-huh.
negative 20.
That's right. 6x squared, 7x, and negative 20. Why negative 20? Isn't it 20, that last term? Yeah.
Because terms are separated by addition.
Terms are separated by addition. That's right. So yeah, these three terms, they have names. Anybody have any guesses as to what they are? Maybe. What about 7x? Any guess? They have names. When they're written this way, especially when it's x to the second power, x to the first, and then some number, each of these terms have names, and we need to know what they are called because I'm going to be referring to them with these names. Does anybody know what they are? No? That's okay, I'll just tell you then. Okay, the names are, the 6x squared is called quadratic term, 7x is called a linear term, and lastly the negative 20 is a constant term. And just like Audrey said, we get the terms are separated by addition, so it's not 20 the last term, it's negative 20, isn't it? So write that down. By the way, what do you think? So, have you heard of linear equations before? That's why we call the 7x linear term. What did linear equation look like? Yes. Y equals mx plus b, and look at the power of x. Is x to the what power? That linear equation. X to the first. You see how this is 7x to the first? That's why it's called a linear term. Okay. 6x squared, why is it called quadratic term? Because doesn't quad mean 4? It should really be not quad, but maybe bi. But I don't know. They call it quadratic term. I don't know. Yeah, do you know why?
I just wonder if it refers to the fact that it's a square.
Right.
Square.
Mm-hmm. Exactly. It's 6x squared, isn't it? So why do they call it quadratic term? Because doesn't quad mean 4? Shouldn't that be 6x to the 4th power or something?
Because, well, squares have equal sides.
Oh, squares has how many sides? 4 equal sides? Maybe that's why it's quad. Maybe, yeah. That could be that. I like that explanation. So that's why it's quad, squares, 4 sides, quadratic term. Thank you. That's great. Yeah. I never even thought of that. Like squares have 4 sides, 4 quad, and this is x to the second power squared. Thank you, I never even thought of it. Thank you, Leah. And so now we know why it's called quadratic terms, right? Quadratic term is because squares, right? This x to the second power squared. What about the last term, constant term? Why do you think it's called constant term? The number by itself. By the way, does number change? Like, does negative 20 become 5 all of a sudden? No, it's what? No, negative 20 is always constant. Okay, that's why it's called constant term. Does that make sense? So the number doesn't change, right? Negative 20 is always negative 20. It'll be bad if negative 20 is like 7 all of a sudden, right? Because then nothing will work. Like you had $7 and now you have negative $20. That'd be bad, wouldn't it? Or the other way around. Maybe it's good if you had negative $20 where you owe somebody $20 and all of a sudden you have $7 or something. That'd be good. But so that's why it's called constant term. Does that make sense? All right. Let's look at then. How do you multiply 2 times 3 times 4? By the way, okay. I know that's a simple question. How do you multiply? Yeah.
Just multiply 2 times 3, then 2 times 3 times 4.
Yeah, which is 6 times 4, right?
Yeah.
Isn't that what we do? Do we do this? 2 times 3 and then do we do 2 times 4 and then multiply those products together? No, then it's wrong. You see what I mean? When you multiply 3 numbers, you multiply how many numbers at a time? 2 numbers at a time, right? You don't distribute this 2 to 3 and 4, do you? Does that make sense? You don't do that, right? Hello? Right? So for them, what do you think if I have this 3 factors for you to, if I ask you to multiply the binomials and a monomial, do you think I should distribute this n to n minus 3 and n to 2n plus 1? Then multiply the whole thing? No, that'll be wrong, right? You see what I mean? Do you see how what do you think I showed you this example? 2 times 3 times 4. what do you think even though it's pretty simple,